looking at here at a graph of, an equation of an exponential function, which we are going to be graphing with a variety of transformations involved, and we're going to do kind of them all at once. We've been looking at a lot of functions and the transformations one at a time, but once you kind of grasp it for one, you kind of grasp it for all, and exponential functions are relatively easy to to graph. So let's get to it. But before we do that, remember, we always have to first rewrite our expression in such a way that we can read out the values easily, the a and the b and the h and the k. So in this case, we have the a value quite easily readable, which is the 3. However, we're going to have to factor out the b value and thereby get a nice h value, which is a shift to the right by 2 units, and we also have a shift up 2 units for the k. So let's take this, because we're going to use it for our mapping notation, paste it here, do it as a paste. I don't want this, cut this out. And let's paste it as an image. Sorry, as something that's scalable. We'll be able to zoom in. And I want to read off the values, the mapping. Okay, so if you recall, it's going to be 1 over b, which is in this case 4, x minus 2, which is our h value, and then we have 3a plus 2. And we're going to use the points for the base graph f of x equals 2 to the exponent x. So I'm not going to do too many points. Let's maybe start off with -2, and that'll be, 1 over 4, my y value. And what does it yield? Well, I'm going to get -2 times 1 over 4, which will be -0.5 minus 2, so -2.5, -2.5. And then I have 3 times a fourth, which is 0.75, so I get 2.75. Next point, I'll look at 0, 1. It's not an equal sign, actually. We're mapping to the point. What do we have here? So with 0, I'm going to get -2. And with 1, I'm going to get a value of 5. And finally, let's just do 2, what is that? 2 to the exponent 2, which is 4. And that will become 1 over 2, so -1.5. And 4 times 3 is 12 plus 2, which is 14. Great, so we have our points. Let's now put them into our grid here. The first one, a slightly larger dot, is going to be -2.5 and 2.75. So that'll be roughly over here, let's say. Over here, -2 and 5, which is going to be roughly over here. And finally, -1.5 and 14, so roughly over here. And I think we kind of get the idea what this graph is going to look like. Okay, if I were to plot it now, again, remember this graph is not going to go below 2 because we do have an asymptote at 2. But there's no reflections going on either in the x or the y-axis. So the original looks like that. This transformed is going to roughly look like that as well. And our graph is going to go something like, oops, maybe not like that, but something like this. Okay, and I know it's kind of sloppy. That's what happens, but the idea is correct. Okay, in fact, if you want to look at something done more neatly, you just bring up Desmos, and there's your graph. As you can see, it actually goes, it crosses the y-axis at some point there, which I didn't mark on mine because it isn't the greatest, but the general shape is the same. And when I'm graphing exponential functions, that's kind of what I'm looking for, is the general shape, the general behavior of this graph reflecting what is in the equation. Okay, if I want to get an exact graph, I pull up some software. I don't need to be too specific when I'm doing it by hand.